Premier Maritime Protection inert gas systems from Air Products have for more than 35 years been installed on nearly 1,000 oil tankers, combination vessels, product tankers and barges around the world. The new Air Products Dry Inert Gas Generator, DIG, is a top modern system for drying, gas-freeing and inerting of LPG and LNG carriers. It is lightweight, compact, automatic and easily maintained. The DIG system consists of an inert gas generator combined with a refrigeration unit and a unit consisting of a cooler, dryer and mist eliminator. Compared with conventional systems, the advantages are numerous. Overall size and weight reduction is about 50%. The adsorbent is more efficient due to the high surface-to-volume ratio inside the dryer rotor. There will be only one adsorber rotor. The operating pressure is lower. The DIG has mechanically simple, reliable centrifugal blowers instead of Roots-type blowers, which means less noise and less power consumption. The dryer rotor has high mechanical strength, is washable and leaves no dust in the dried gas. This rotor dryer has been used for drying air on board ships and has 10 years of seagoing experience as such. In the DIG system, the rotating dryer is used for drying inert gas on ships for the first time. The dew point of the gas is actually decreased with the time the system operates, contrary to the conventional systems where adsorbent tanks are saturated by longer operating time. The unique feature of the Air Products DIG design is that when operating in dry air mode, only the cooler and dryer is used. The whole inert gas generator, with its combustion air blower, its fuel pumps and its seawater cooling pumps, is not needed. In dry air mode, the dry gas blower only sucks the ambient air through the cooler and dryer for dehumidification, drying and distribution. All competitive systems use the complete inert gas system in addition to the cooler and dryer when drying air. The consequences for the conventional systems are considerably higher power consumption in the combustion air blower and the seawater pump, and also a heavier load on the refrigeration plant as the air through the inert gas generator is in direct contact with seawater in the scrubber, resulting in a much higher dew point at the inlet of the cooler than the ambient air. Due to the high number of annual operating hours in the dry air mode, it is estimated that competitive systems have a 75 to 100% higher power consumption than the Air Products DIG system. The plant has two main operating modes. Dry inert gas mode is used for inerting the cargo tanks and the associated piping system prior to and after each dry docking. This operation will take approximately 20 hours. When running in this mode, the complete system is in operation. Dry air mode is primarily used for a weekly purging of the surrounding void spaces outside of the cargo tanks in order to maintain a dry atmosphere at all times. This mode is also used during dry docking. A three-step process is executed in the DIG system: combustion, cooling and drying. The air to the combustion chamber is delivered by a single-stage centrifugal type blower designed to carry 100% of the inert gas capacity. The inert gas generator consists of a pilot and main burner, a combustion chamber and a scrubber unit. The pilot burner is fitted with separate gas, oil and air supplies. When the plant is started, the pilot burner is ignited, which in turn ignites the main burner. The generation of inert gas is performed in a combustion chamber where atomized fuel and air is reacting to form the inert gas. If the burner receives more air from the blower than required, surplus air is ventilated from the front of the generator by a separate atmosphere outlet. The heat of combustion is removed by a steady supply of seawater flowing in the double-walled cooling jacket surrounding the combustion chamber. The lower part of the scrubber tower receives the hot inert gas from the combustion chamber. Up through the scrubber, the gas is cooled and cleaned by an intensive countercurrent of sprayed seawater. A demister in the upper part of the tower removes entrained droplets before the gas leaves via the inert gas outlet. The seawater from the spray nozzles leaves the scrubber by the bottom drain line. The generator has now produced a humid inert gas with dew point plus 35 to 40 degrees Celsius, depending on the seawater temperature. The cooler mounted on the dry skid is of the fin type, and it is served by the standalone refrigeration unit via a chilled water loop. The cooling medium of the chilled water loop consists of a mixture of glycol and water and is circulated by a centrifugal water pump. The cooler reduces the humidity of the passing inert gas or air to a dew point of about plus 4 to 5 degrees Celsius. The condensed water leaves the cooler by a bottom drain line. From the cooler, the cooled and saturated inert gas or air is passed through a high-efficiency filter to eliminate any mist due to gas saturation. The filter pads are installed in cassettes for easy side removal. The inert gas is finally dehumidified in a rotating adsorption dryer. This is a heat-regenerated dryer, where the drying is performed by a metal silicate rotor with high adsorption capacity. The dryer cross-section is divided in a 180 degrees sector for drying the inert gas, a 90 degrees sector for the regeneration of the rotor, and a 90 degrees sector for the cooling of the rotor. The moisture of the inert gas passing the bottom 180 degrees sector is deposited in the rotating dryer wheel. The temperature of the cold inert gas passing the rotor in the cooling sector is raised to about 120 degrees Celsius before being passed through the regeneration sector of the rotor, where it picks up the moisture deposited in the drying sector. The wet gas leaving the regeneration sector is transported by the wet gas blower to the cooler inlet. This forms a recirculation loop of wet gas. The dry rotor is actually transporting the moisture in the main stream to the recirculation loop, so it finally can be removed in the cooler. The dryer reduces the inert gas or air humidity by adsorption to a saturation point between minus 45 degrees and minus 65 degrees Celsius. The dry inert gas or dry air blower, identical to the combustion air blower, sucks the dry inert gas from the dryer skid to increase the pressure downstream the dryer skid to the required delivery pressure. The operating pressure inside the dryer skid is near to atmospheric. The dry inert gas generator is built in accordance with the 1974 Solus Convention with latest amendments and is fulfilling all of the IMO guidelines and the demanding conditions of shipboard operation. As a market leader since 1970, Air Products has accumulated considerable experience in the inert gas business, which is well taken care of by a stable workforce. Air Products in Kristiansand, Norway is a member of the Air Products Group, which employs more than 22,000 people worldwide. The Air Products Group is a leading international supplier of industrial gas and equipment, chemicals, environmental and energy products.